Hi there. Welcome to another live stream. In this live coding session, I'm actually working on visualizing a neural network with Blender and Python. So you can see here what I've managed to do in my last live stream. So right now I'm just working on two layers of the neural network. I'm working on the part of the neural network that is fully connected. Okay, so this is the first. Well, I mean, I've done good progress, but obviously this looks very artificial. It looks, yeah. So what I want to do, I have a few things I plan to do today. Actually, let me just. So I'm planning to, first of all, I want to see if I can add a gap to these neurons, right? And then still be able to have all these connections going to the right places. So that's the first thing I wanted to do. Of course, I'm going to, right now this is too big for me to actually work quickly. So I'm going to reduce the number of neurons for now, just so that I can easily make changes and run the code again. Another thing I'm going to be doing, I'm going to try and optimize this because right now I'm using cylinders for the connections between neurons. And to be honest, I think because I'm going to make this really thin, right? You wouldn't know if this is a cylinder or or even like a cube, right? So you wouldn't know. So I think I'm going to replace with cubes, and then just to make it more efficient. And I'm going to try and use NumPy to initialize the objects rather than using operations in Blender, which seem to be quite heavy. Okay, without further ado, let's get started. Okay, so first thing I'm going to do, I'm going to the script, and I'm going to change this to have less nodes for now. Yeah, so right now I have 16 by 16. I'm going to make this 4 by 4, and then 2 by 2. Okay, just to make it easier. Hi there, Ethan. Welcome to the live stream. If you have any questions, let me know. Just put, just use the chat. Okay, so I have here, okay, a much smaller neural network. I'm going to delete the previous one. Wow, it's huge. Wow, how many cylinders I have here. I think a bit more than I expected, to be honest. What? How many connections I have? So I have, yeah, it's a lot. So 4,000 cylinders, right? So I need to select all of this. Let me just see. Or we can do it. Okay, and then I'll delete all of them. And I can start again. So I'm going to run this again with less nodes. I just upgraded to the latest version of Blender, so I'm not even sure how this. I know they've improved certain things, like the arrows are in a different place now. Let me just run this again. Not sure what's happening. See, Windows toggle system console. So here, this is our, okay, it's actually working. For some reason, still created quite a few connections. Okay, so we have now a much simpler neural network, and this is just to make it easy for me to debug. Okay, so the first thing I want to do is to try and add a gap between these cylinders, right? Right now, the ArrayModifier is without a gap. And so I'm going to try and add a gap to it. Feel free to ask questions. Okay, so I have here, connect neurons, connect layers, and neurons layer. Okay. So here I can specify a gap. So right now is 1, which means no space in between. It might be a good idea to just go and have a look at the documentation for Blender. So Blender ArrayModifier. Just open that up, and I should be able to also see the settings I have. So I'm going to look at my first cylinder. First cylinder is basically what is originated the copy of cylinders. Okay, and I can have a look here at the I see your question is if we can do GAN on Blender API Python. You can generate 3D models using GANs. That's possible. Maybe that's something I'll think about doing in the future. I know there's some generative models out there. I can take a look. Yeah. Okay, so the ArrayModifier should be here. But this one doesn't. Okay, object mode. Yeah, I'll be trying many things. So yeah, it sounds like a fun project to do. Okay. So I can, if I add displacement here like 1.25, right? I know this is going to mess everything up right now, but oh, this is cylinder, not the sphere. I was looking at the wrong thing. I see. Okay, so scripting. Okay, let's run the script again. See what happens. Okay, so I added gaps. It shouldn't work, to be honest, but let me add a bigger gap. I wasn't expecting it to work. No, it shouldn't work. Yeah, okay, so I added the gap, which is so basically 1.25 times the size of the sphere. But I don't like this type of gap because so 1.0. Let's run this again. everything without a gap again. And I just want to... I wonder why I can't see the... the basic sphere. Okay, this is the one I'm using right now. I'm using a relative offset, but I think I want to have maybe a constant offset. It's easier. Distance X, Y, and Z. Instead of using relative offset, I can use a distance offset. Let me try. So just commenting this out. And I'm going to distance offset displays. I'm going to assume it's the same name. Select objects and delete everything, and then I'll try again. So I'm just exploring a bit the ArrayModifier, just to see other options I have in terms of like, well, yeah, this didn't work very well, did it? So let me see there. Distance offset, okay. Anyway, I can just try. Should be able to try manually. Oh yeah, this one has. Well, I can see it here, but I couldn't see for the relative offset. Okay, so I'll remove this, and I can do constant offset, and then I can do a distance like 10. Okay, you see. So the distance between the two center points are probably like 10, right? So 5. What did I get to that? 5. Yeah, I really like much more this property. constant offset displacement. So 2 meters. So 1. So 1 meter is basically depending on which radius we have. So this is radius 1, right? That's why it would work. So 1 meter distance should be like almost in touching distance. So this is the same as saying relative offset. Oh, I can even combine both. Wow. So 1, 1, and then 1, okay, or 0. So this is the same. And I didn't know I could combine both. Wow. Oh, I see. So if I say 0 here, it's just going to be together. So I can have a relative offset and a constant offset all specified at once. Okay. That's cool. Does it really matter? I mean, I could just have a constant offset and specify. But then this would have to be based on the width. If I specify relative offset of 1, then I only have to worry about the distance between the two objects regardless how big they are each. So I don't have to worry about how big each one is. Yeah. Okay, cool. So let me just try and use this. I need to set up, there's something in Blender that allows you to see what each property is, what is the name of each property in Python. And I need to enable that. So where's the preferences? This window, edit, preferences. So there should be a Python Tooltips, yeah? Yeah, here, right. So I specified Python Tooltips and I should be able to see the property. Yeah, you can see it now. So constant offset displays. So if I go back to the code, constant, oh, I already have constant offset displays. Okay, and I can specify a distance here. Can also specify a relative offset displays. Let's try again. Okay, so we have, okay, you can see, didn't seem to make a difference. Maybe I made a mistake. Let me see. Okay, so seems like I didn't get it right. So it's really strange. I don't see the neuron. I don't see the modifier for some reason. So I have two modifiers. Okay, let me just check something. So Go into modeling. I'm going to add another modifier, doesn't matter. Just trying to see the properties. So array. I need to specify use relative offset. Okay, there's a property called use relative offset. So mod dot use relative offset equal to true. And there should be another one for constant offset as well. Use constant offset. Yeah, let's do again a new trial. Delete. Right. Okay. Run again. Let's have a look at the result. Okay, so there is a gap now. Okay, of course my connections are messed up, but this is exactly what I wanted. Okay, there's only a vertical gap. Okay. And we can try and include that. Okay, I have like a very... Actually, something I was thinking about, you know. This is an object. If I do a subdivide, I can actually convert this to... Basically, I can actually separate into objects. For object. Need to check the documentation. I don't remember. So Blender divide object into separate geometries. There's a way to separate. So I'm trying to just point out. Okay, this is I just want to try this by hand, see what happens. Right, so P, apparently there is select all vertices, but I need to do this in edit mode. There used to be, okay, A is basically to select everything. Hi, good afternoon, Sherry, nice to see you again. Hi, Mustafa. So what time is it now for you? Now I have, what happened here? I thought that Control Z, that's not what I wanted to do. So I was trying to see if I could subdivide all these objects. Oh, I see. I did manage to do that. Okay. I found out that with ArrayModifier, okay, you can actually subdivide it into separate objects. Oh, New Zealand, nice. I once wanted to live in New Zealand, but it's really far away. Oh, it's Independence Day for Pakistan and India. Nice. Right, so we have... So should I just use this? What's the vertical center of this? So let me just see. I don't know if I want to do this. Perfect. So let me just see. What is the center of this? Oh. You see, I installed the latest version of Blender, and now I'm figuring out as well what changed. So the N used to allow me to see like the dimensions. Now I can see NVIDIA Omniverse. Seems like they paid good money to be there. How do I show? View. Okay, yeah, this one. So I want to see this. So I'm in object mode. So location. Oh. No, this is a 3D cursor. I don't want to see the 3D cursor. I want to see the actual object. Okay, so Mustafa, what I'm doing now, I think you saw the picture, right? That I already can create a fully connected layer, and I'm trying to basically add a gap now between the neurons, so that this still works, right? And these connections, they need to follow as well. But I'm also trying to figure out certain things that I didn't know I could do before. So it seems like, okay, I'm going to delete all of these, right? So you can see. Yeah, so if I run this script, it should create everything from scratch again. And then we have here, okay, this is, okay, with my code, I've already messed it up. Let me just put this back to a place where it's actually working. So I've added a gap. Where did I put that? Yeah, here I added a gap. So I can just do 0 for now. So I already can do a fully connected layer. Thanks a lot last time for finding that function on Stack Overflow. Yeah, so you can see this here, right? So now I just want to basically, before I try to do anything more complicated than this, right? Or even to, before I even try to create thousands of neurons and thousands of connections, I want to just improve what I have already here. So I want to replace, first of all, I have an array modifier here. So you can see, right? This is actually one big piece, right? It turns out I can actually subdivide this object. This is a single object right now. Okay, I can subdivide it by pressing well, in the keyboard I can do it. I'm sure in Python I can also do that. So P, and then I can separate by loose parts, right? So I can actually do this. So if I go, see, oh, I guess because they are touching each other, maybe it doesn't work. Okay, so let me just do it. Oh yeah, I need to select everything. So, and then press P, and then specify separate by loose parts, and then I can treat each object as a single, a separate object. So I have like, instead of just one big object, I have like all the neurons I want. And this is much more efficient, I guess, than creating everything using the function that Blender gives you to create a sphere each time. If you have to create 10 spheres, it's much slower than creating 10 spheres with an array modifier. Okay, so I can do that. And I was just trying to understand what is the center of these, whether these objects actually have all the properties working properly, but I don't even know where is the actual, how do I show the dimensions of this? I used to be able to press N and it was showing me, oh, the item here. Okay, I got it. So I can see now that the location of this item is 0. Let me just change here. So 10. Interesting, right? What? Oh. So something weird with this. So I think the center of this sphere is not set correctly. Because all of them say they are in location 0, 0, 0. So what is going on? I guess because these are like are these like relative coordinates? So the center should be here. -1, -0.5. Okay. So this is all relative. Okay, I probably won't mess around too much with this. Maybe I can just do, I would have to change the set origin to 3D cursor, right? And then, well, it doesn't seem to work. Okay, right. I'm not going to. Right, I'm going to try and do some progress, but I'm going to avoid this problem for now. I don't need to subdivide this yet. I don't need the separate objects yet. So I'm going to do it this. And I'm going to create again. Okay, so the idea is I want to change, add a distance between each neuron, right? And then I want to make sure also the connections, all the coordinates are also changed. So if I go to modeling, so you can see as soon as I add the distance, then I lose these connections, they don't follow. And that's because I created a function that just kind of guesses where the each sphere is, but it doesn't really know. It just I just kind of assumed that they would be there based on the fact that I knew there was no gap between the neurons, and I just calculated this neuron grid using a NumPy array function. So what I need to do is basically just say, I need to add a gap, right? So it shouldn't be too difficult. So I have a start x. This is my starting point. And then I need to add maybe let's add an extra function. I'm going to add an extra property here, gap. And I can specify maybe a gap for x, y, and z. So I can put 0, 0, 0 for now. Yeah. And then if I add gap equal to plus here, right? So I should be able to just add a gap here, and I should be able to get all the coordinates correctly, right? So the gap should always be at the end. So not for the first one. So neuron coordinate x. Start x. Okay, what am I doing here? So x. Oh, I see. So for each column, so if column equal to 0, this is going to be start x. If column equal to 1, this is going to be okay. Call width. But I need to add a gap. So plus gap. And there will be as many gaps as columns, right? Look. So call index plus times gap. I'm going to call it x. So gap x, gap y, gap z is going to be equal to gap. Okay. So I'm just going to specify 1 for now here. Let me just do connect neurons. Okay, for now I'm going to default it. Afterwards I'm going to change this to add a passer parameter. Okay, so 1. That should match the gap that I specified already in ArrayModifier. I know this is not great, but you know, I'll improve this later. So modeling, let me just run this script again, and I should be able to have something working. Oh, it's almost, it went to the wrong side, the gap, didn't it? Oh, what did I do wrong? So gap. In fact, it should be like this. What's wrong with this? Okay, this should be. Yeah, I'm actually just adding an extra gap. It shouldn't be. Okay, maybe I didn't do that for. Did I do wrong? Let's see. So this guy. So this is 4.5. It's kind of almost like it's the wrong side. So 4.5. Because the center is here. Let's see. So I could divide it by 2. So do this scripting. Okay. Let's see what's wrong. Okay, I know what is wrong. I didn't take into account that the width and the height is different, right? So I'm going to change that here. But I need to put this at the top. So width is going to be number of columns times neuron size plus gap x. Yeah. So select delete. And I'm just going to run this now. And I can see I did wrong here, but I'm getting close. Oh, what did I do wrong again? It should be gap. Okay, so if column is equal to, what did I? So if I have like four neurons, The gap is 3. Okay. So this is not exactly correct. So plus gap times calls minus 1. And I can transform that actually to something. This is so calls times neuron size plus gap times calls minus gap. Sure if this looks better or not, but so basically I'm just taking one gap out. So I can just simplify this to, like I had before, actually I can put back calls times neuron size plus gap minus gap. And I can, yeah, all right. And then I have something like an expression here. Let's see how it goes. Calls times, I don't need this bracket. You are setting a point that has a setback. I don't understand the question, sorry. Right, so we have here, what is going on? Why is it not? Okay, we have gaps, but what happened to the actual connections? There must have some error. So view, so window, scripting, window, here. Where is it? 134. So I have an error here. What's wrong with it? Doesn't seem to be. It's oh, I see. Okay, I missed something fundamental here. Gap X. So run this. Okay. Still messed up, but why is it messed up? So the first one is actually correct. Then I add too much of a gap. Then even more. Oh. Okay, same problem here. Okay, got it. Colon index 0. One. Okay, so cool. I see, because I'm also using the full width. Right. Oh. The full height, including the gap, then I divide this by number of rows. Don't think I need this. Not here. So 1. So sphere is 1. So if I have 4 columns, so 4 spheres. So I have subobjects delete. 2, 3, 4. So 1, 2, 3, 4. And then each gap. So it's 1, 2, 3. So 7. That's the total width. So it should be number of columns 4 times neuron size, which is 4. One, 2, so 4 times 2 is 8 minus 1, 7. That's correct. Okay, and then for the start index, so it should be, so I don't know why we need this. No, okay, column width should be the neuron size. For now. I don't think it even makes sense, the name anymore. Okay, so it should. Okay, so it should be okay now. Right, so I have managed to get the center. Okay, so I have. Okay, cool. So now I can get horizontal gaps. Now I need to have vertical gaps as well. So vertical gaps I can add via the same idea, right? So I'm going to add neuron size plus gap Z. Let's do that, Z. Then we have Z, and then I also have to specify the offset here. So right now I only specified a distance offset . I think I have to do it here. Here, 1. So I can run this now. Didn't work very well. I think because I just got something wrong. What did I do wrong? Oh, I see. It's the wrong thing. So 0, 2, 2, 2. So made a mistake somewhere. exactly where I made a mistake. Right, to neuron size. So here. Okay, yeah, so it's minus gap z. Okay. Run again. Okay, we have now something that I can now already vary the distance between each neuron. So I'll make this like a parameter rather than right now it's just so calculate neural grid. So I'll make it 2 just to make it different. Okay. And then I also want to have, actually I can have a gap here. So gap equal to 1, 0, 1, 2, 0, 2. And then we have gap. I just passed that gap equal to gap. It doesn't matter. Okay, so let's try that now. Delete. Okay, save. And we have what? I made the mistake. So let me see. So I've specified. Oh, because I'm not passing. I'm not taking the values yet. Yeah. So gap x, gap y, and gap z. I'm actually not going to use gap y at all. For now, I'm going to leave it like this. Put the gap. Yeah. Then I can specify here for the distance. That's why I wanted to have a constant offset so it's easier to specify. So I'm going to put distance equal to gap. In this case, this is gap x. And then this one is gap z. Select all the objects, delete, and try again. Okay, so this looks right, isn't it? I could even do like random distances, but yeah, I can make this more complicated. But for now, I think this is enough, right? Yeah, so this is a fully connected neural network. Okay, it's actually very small right now, but okay, this is good enough. Right, what I wanted to do next, let's see how much time I have. Okay, so I wanted to replace this. These are connections between spheres, right? These are cylinders, right? This is a very inefficient operation right now. It takes me a lot of time to create one of these. But yeah, the point is, if I want to create thousands and thousands of these, how do I do it efficiently? So there's a way to do it. I could probably try to. I have here this. So this is an article on how to create a cube from like using a NumPy array. So I could just use Blender to create a cube, and this is a very efficient way of doing it, as far as I know. Instead of using the bpy like the operations API, which is this one. I could just use a NumPy array and specify all the vertices and skip all of this, which is a very this is actually doing a lot of things in the background. It's not efficient. There is another there are some other functions I probably can use in Blender. So I could also try to create an instance. Anyway, so let me just see. So this is using. Okay, I can try this code, yeah? Let's just try it. See if it still works in this version of Blender. I'm going to do it all of this for the time being. Yeah. And I'm going to comment out some of this code. Yeah. Might as well do it this. And I can put here the cube. So this is the very traditional cube. So let's see if it works. Seems like it did work. Yeah, so this this is a function to create a cube, okay? And one thing I wanted to do, I'm going to mimic the cylinder function, and you can see there is a function here that creates a cylinder. I'm going to call it as well because I want to make sure that my new function that I'm going to create is going to have the same position. I want the cube to have the same position as cylinder, right? So I want it to work more or less the same way. Because then I'm going to do some rotations on it, right? And I want to use the same function without changing it. You know, this bit here, the rotations is something it took me a long time to get it to work, and I don't want to have to figure out again. So I want to make sure that I'm not doing anything special. Why is it now copying? Copy. Oops. Let's copy that. We have, so I'm going to make the radius 1, this depth I'm going to make it 1 for now, everything 1. Yeah, where is the cylinder? So you can't see the cylinder because it's okay. So see, the cylinder is here. I think they both have the same origin, right? Okay. If I make a wireframe, you can see it's here. Okay. But I want to make sure they are okay. The actual height, it doesn't matter, right? Because we can, it's going to be based on how big the connections are between neurons. But then another thing I wanted to make sure is that, so in here, I'm specifying a location. Yes, I can. Where's the location? Yeah, it's based on my. It's probably the same thing, isn't it? So if I specify a location, do this. This copy is not working very well. location. So cylinder dot location equal to 2, 2, 2. Yeah, and then I want to also do the same for my object. So new object dot location equal to 2, 2, 2. Let's see if they are in the same place. The thing is, I'm going to make the connections between neurons so thin that even if it's a cube, you won't even know, right? Okay. 2, 2, 2. Kind of looks, yeah, it's all good, right? The scale, don't know if the scale I can change it as well. Can I change? So how can I make this bigger? So these are the vertices. Scale. Yeah, let's do scale. Equal to, let's do 10. I don't know if I can do a, I think it's also a coordinates, right? You can do 10, 10, 10. Okay, yeah, it definitely works like that. And you can see the same thing for, so cylinder. Ah. Cylinder dot size, what? Cylinder dot scale equal to 10, 10, 10. So my hope is that it's a lot faster to create all these cubes than a cylinder, because I know for sure it is faster, but let's see how big the difference is. Okay, you can see, well, the scale, okay, the scale doesn't tell you how big it is anyway. And for the cube, so dimensions 20. So it's actually 2. Okay, I got it. So one thing I do need to adjust is this. So instead of making it, I want to make it like a perfect like unit. So 0. So instead of having 1 and minus 1, I want to make it 0.5. Wait, don't want to make a mistake. Minus 1, minus. Okay. It's a very rough way of doing it, but it should do the job. So I can just define afterwards a function that creates a cube. With the correct dimensions I want. Then I can do like just like a straight replace. Okay, so let's try again. You can see now it's very much the same. There's some mistakes here I made, I'm sure. It's not in the center, is it? So something went wrong. sense. Yeah, it doesn't really matter then. Actually, I should probably not try to complicate this too much. Because, yeah, I might have missed one. I don't really want to risk it. Okay, so I can still make it work, no worries. Okay, I'm going to take this and define a function. So I'm going to copy this and then create cube. Yeah. So this is going to be my cube, right? So this is the primitive I'm using for the creating the connections, and I'm going to pass in a size. I think a size, that's kind of what I need to pass anyway. So size is going to be, so that will be a depth. Okay, so I don't care about how the width, you know, that's going to be, so there's the height. So there is a depth. And so the radius I can call it this. Oh, let's call it the same, yeah, radius. createCube. So I have a depth and then radius. Kind of, let's just call it something like that makes sense in terms of geometry. So what width and height. And I can default. So I don't really care too much about the width. I can actually make that as a constant parameter later. So I can make it to like 0. For now, let's make it 1, but later on I'm going to change this to 0.0.1 or something like that. So createCube, height and width. Yeah. So scale. So we already know that our cube by default has like a height of 2. So height. So scale will be height divided by 2. So if I want like 1 of height, then scale will be 0.5 to make it smaller. This is for X, so then we have Y and then we have Z. So the only scale I want to change, okay, so we have X, Y, and Z. The only one I want to change is the Z, really. So 10. So let's do Z for height. Yeah, and then the other ones will be like width. Not sure how that's going to look, but we'll see. Let's see. Let's just try and see what we get. Right, so createCube. I'm just going to call this function. So instead of this, createCube. create cube, and I want 1, 1. So 1. That's going to be my depth. The other one is going to default to 1 as well. So let's see if we get anything close to what we want. Okay, this cylinder, I don't need it for now. I have 2 for some reason. Let's specify a location, right? So the dimensions is like 1, 1, 1. That's what we want. This is exactly what we want. And then a location is exactly where we want it as well. So if I put this in the center, it should be well centered as well. Yeah, it's all good. All right, so I have my cube function working. I probably want to, you know, instead of just saying new object, I want to have like a proper name, like yeah, I'll add it later. So what else do we want to do here? We have, because the location is here. Okay, the location as well, that could be an argument. So location. Okay. For location. Right now it's being hard-coded. Location. Then we can put location here. Yeah. I mean, you can't see inside. There's a cuboids there. So let's, okay, I think I can get rid of this guy. Yeah, and then I'm going to use this here in connections, connect neurons. So instead of calling instead of creating the cylinder, I need to work out later on. Okay, I'm going to use create a cube here. So cube equal to, then we pass in the coordinates, like the depth will be so this will be the distance, so how tall I want it to be, and then the location will be based on this algorithm here. Location, yeah, and then okay, this gap stays like the same. Then instead of rotating the cylinder, I'm going to be rotating the cube. Obviously, I need to make sure the cube is much thinner, so I'm going to make it 0.01. So create cube. I hope this works. Okay. Let's see. So there's an error. So we get the errors here now with this. Okay, so we have I need a bracket somewhere. I'm missing, oh, I have too many maybe. Let's try again. Okay, another error. What's going on? So let's try and run it. So what happened? Oh, maybe I'm not adding it. I'm not adding these cubes to any place. Cube. Oh, I know why. I know why. Okay, it's because I'm not actually creating the layers. So let's do this. So we have some errors. No attribute name. Line, what, 219? I can actually give it a name, right? Let me just give it a name. It should be a name there. Name. Let's see what happens. Okay, because it's non-type, so it's not so much because I know what it is. Okay, right, I know it. Right, what is the name? The name is, okay, let me delete this. All of this I have to tidy up. So return, so I need to return the object, so return new object. And now okay, it should be working now. Can you see? Do you notice the difference between the two? I don't. So actually these are, instead of just being like normal cylinders, you can see now when I make it very high resolution, you can see this is a cube connection. So it should be much faster, right? And what I want to try now is just to go a little bit above and beyond. Maybe I'm going to remove all this debug because it's slowing down Blender. So I'm going to, or maybe I'll do that later because otherwise I don't know if it's actually working or it's just hanging. So I'm going to put, instead of number of nodes 4, I'm going to make it 16 times 16. So this should already start giving us a lot of trouble, you know, in terms of, this is going to double 16 times 16. That should be a lot already. Select objects, delete. I just hope this is much faster. We can see it's much faster. Well, you didn't see my previous live stream, but it took me a lot longer to create a neural network this size. Okay, this is starting to look a lot more like a proper neural network, right? Of course, I still think these spheres are too big, right? I think I should make it smaller. But you can see already this is becoming interesting. And I can actually go a little bit more crazy. Let's just double the number of nodes. And this is going to become a bit huge. This is start, I might actually crash Blender, right? So if you don't hear me, right? I might have crashed, it might be because I crashed Blender on my computer. So I might go offline if I get this too much. So 32 times 32, just to give you an idea of how many connections we're talking about. So 32 times 32 is 1024 neurons, right? So each neuron has a connection to, so this is one layer, right? So one layer has 1024 neurons, and this one has, the second layer has 16 neurons. So each neuron here connects to the 4 neurons in, well, 16 neurons in the other layer. So if I do times 16, this is going to be a total of 16,000 connections. I don't know if I can actually draw this without crashing, but let's 16. Yeah, I will try and see what happens. But I have a bad feeling about this. But you know what? I don't necessarily need to draw all the connections, because yeah, I don't know if this is a good idea really. So 16 times 16. So if I go a little bit, let's go 20, 20. Just go a bit like more, instead of just doubling it, I'm just going to go a little bit bigger numbers, but so we know what the limits are. Okay. So this is not too bad actually. You can see. I can make this much smaller and it will make it more like a neuron. And one of my ideas is to try and animate the neurons and have like different like neurons come on and off depending on what actual neural network is calculating. Because when you do a prediction, basically all these neurons will have a value of either on or off, right? So you can actually make a state for on and a state for off. Okay, so 20 is okay. Let's do 25, 25. And delete. Sign. Okay. So that's why I had to spend, the reason why I had to spend time replacing my cylinders with the cube, and I was really just trying to make things a little bit more efficient, because I know as soon as I increase these numbers, it becomes very computationally and memory-wise, it's going to be quite high as well. But it seems like Blender is scoping so far. But you see, it's already starting to struggle. I'm not surprised. But look, and it's probably slowing down because of this. Wow. I could also make these, this is almost like a grid, right? I could try to randomize positions, but yeah, I don't think it's huge. Okay. Right. And let me, do I really want to go to the limits of this? Maybe. I might do, yeah, okay, let's do this. I'm going to check the limits offline. So even if I crash Blender, it doesn't matter. I won't crash the live stream, but yeah, I will probably post something on the community tab. You know, don't forget to subscribe and like it, the stream, if you find it useful. That will definitely help. Yeah. Okay, so we have this more or less working. Okay, I'm quite happy, to be honest. I can make some adjustments, right? Let me just make all this a bit smaller. we probably can start looking into what I'm going to be doing next, like looking at the materials, animation. It takes a long time to delete all of this. The cool thing is that once we work out all the animations, right, we can actually light the connections, the synapses. We can make them go bright. Right, so let me just run. Okay, where is it? The script is here. So let me just do, instead of, so the neurons layer. Okay, I'm going to leave the numbers as they are. And I'm going to specify, okay, let me just clean up a little bit of this code. I don't need it anymore. Maybe comment this out as well. It's a bit faster without it. Don't need this. Don't need this as well. The size. So createCube. Connect neurons. So neuron size, I can try and change the number here. I hope this is not hard-coded elsewhere. I'll find out. Yeah, so let's make it 0. Okay, let's do 0.1 first, because otherwise, oh, what did I do? Okay, let's do 0.1 and see what happens. It still has a lot of debug. As you can see, it's doing a lot of work in the background. Yeah, let's see. So modeling. Wow. Okay, so it's starting to look a lot more like a neural network, right? So you almost can't see the connections, right? The neurons. So there's a gap. I can make it. I can change the gap as much as I want. I can make each neuron bigger or smaller, and this is very cool, actually. All right, so we have this done, and I wanted to explore now animations and materials. Maybe I don't think I will have time to do all of this here, but so I need to think. So if I go into the texture rendering mode, you know, I want to be able to see, let's do shading because it's easier. Okay, this is where each of these connections. So I can, in Blender, I can animate things in a timeline. So there's a timeline that I can use for animation. And then I can change the colors and materials of things, you know, during that timeline, you know, it's here. So I can even move. I can probably change the thickness of each connection depending on, you see, or make the color change, you know, something like this to basically simulate like the connections becoming active. But to be honest, this is like a very starting to get a bit more complicated. So I wanted to start very simple. I have okay, let's start with just the materials. And this is, to be honest, for me, it's going to be more like a learning process of, because I'm not like, well, I'm not like normally, I'm not a regular user of Blender, right? So for me, all of this art is going to be more difficult now because I'm not an artist. But, you know, let's just see what we can do with some. So I'm just going to go and play a little bit with Blender. If anyone here actually is a Blender expert, let me know, because you can always help. So I'm going to try and change the materials. So there should be one thing I do know is that we have like, okay, we have geometry nodes. I kind of played with geometry nodes in the past, but then there's another, I think it's in shading, right? There's like a material composition as well. Okay, yeah, something like this. And I can play with this and understand how it works. Material output. Okay, let me just find the tutorial. I kind of did one a long time ago myself. What are the materials? So I have one tutorial somewhere. If I can find. Luckily, you know, I do write articles, so whenever I learn something new, I normally take note of it. So I can actually specify. So Blender allows you to do everything via Python API, but of course it always helps if you know how to use the interface and do things first by hand, and then you can automate it with Python. That's how I do it. So I do watch a lot of, I might have to watch my own tutorial again. God, I completely forgot. I see. So the idea is, right, for each object, we can assign a material. Okay, we have thousands of objects, right? But we don't need to create a material for each object. We can create one material and assign it to every object, or we can create like a list of materials and then assign it, you know, like we can have some kind of logic. We can assign maybe 10 materials and we spread it across our model. But I could actually create, I could just use this code, to be honest. Yeah, I think I have some problem here. Okay, so this is math. Okay, I'm going to just copy and paste this. It's my own script, so I used this in the past. So let's see what happens, you know, if I just specify a material. So I'm going to do for the neurons first, because they are much less. So create neuron. Okay, I don't want to create more than one material. So what should I do? Should I just create a material per layer? I think I can for now. So yeah, let's do that. All default names, doesn't matter. It's very simple actually. Okay. By default, actually, it uses a material is in PrincipledBSDF. And there is this video here. I actually recommend an article. It's very good for actually understanding how materials work in Blender. So it's a good video to watch. And I'm just going to copy all this code for now. So maybe we start with the cube, right? Because, you know, I already have a function for the cube, so we can do. Yeah, so we don't have to wait so long to just see the results. So let's do like one cube. Yeah, and then we can do something more complex. So create cube, 1 height, 1 out and 0, and in origin. Okay. So I'm just going to run that. So cube. I'm going to delete all the other objects for now. And I will saved. So I'm just deleting all the objects. This massive amount of neurons so I have. I'm not sure whether it's already crashed. I did save it. So even if it crashes, I'm okay with that. Yeah, I don't know if it's crashed or not. I'll just stop it. Blender, start again. To make sure it fits into the window. Yeah, just open again. Then we have 79 megabytes already. Okay, so I'm going to select all the objects and then delete. I should do. Delete. You can see Blender struggling. This is a lot. In the meantime, I can always go to the article because I think it just takes time. Okay, so I created the material using the API. Okay, it's already done. And then I added, okay, let's go back to so let's create a cube, right? So I will have a cube as an example. Okay, this is okay, I'm going to just make a normal cube, like the one we normally have. Why is it? Width equal to 1. We have render. Okay, so we have a cube, nothing special there. Yeah. But then I can apply the materials to this example object and see just roughly how it's going to look like. So createCube. Where's the code? So we have the material here. Then we just add that to the cube. So a material can be shared by as many objects as you want. And then we have mat.useNodes. So we are using the composite nodes that in Blender. We'll see that this is for using nodes. So we can, I mean, there's a lot of things we can do here, but obviously it takes a bit of a course to actually understand how to make it more realistic. And today I'm not going to make it very realistic. I'm just trying to add the material. Oh, it will be something like this. Then I'll be curious if you would like to contribute to this project. Maybe you can provide an example of how a definition of a material that we can use that will look cool. Okay, so we have material. So this is just the Python code to do some very basic, create a very basic material. I don't even know if this still works on the current API, because this was done for an earlier version of Blender. It might have changed. Okay, so let's see. If it looks half decent, I will go with it. For now, it's not. I'm not too focused on the visuals. What was the error? So I have an error. So it's saying that syntax error. But this one should be easy to solve. So I have a syntax error here because I copy and paste the same line twice. I had two lines in one. Okay, so let me run again. And it seems like, it looks like it worked. So I have the cube still. And then if I go to shading, I have some shading here already, right? This is the color that I had picked in the tutorial. But where are my nodes? Okay, if I select the node, you can see here, I can actually refine this, change the color. If it's a neural network, it should be something more closer to white, right? And translucent as well. You should make it translucent or something, like a bit shine. Oh, that color which is more like how do you call it? It's emits light, you know. Okay, so we have here an example of a material which I can apply to, for example, I could apply this to all the neurons in our neural network. I wish I could do transmission. What's that? Let me just play a little bit with this. Maybe I'll find some like really cool. Oh, emission. Yeah, this is what I want to see. Is like a way to emit. Of course, I only have code. So transmission. backward tuned. So I think if I spend actually a good amount of time looking at all the material properties in Blender, I can create something very cool. I wanted something that emits light, like let me see if there's an example. Principled. Emission. Let's see if there's any cool, like something like this. Strong emission. Because that's like a neuron should have emission, right, of light. There's the emission maps. I think I want something simple for now. Oh, I see. So maybe because of the way I'm rendering it. Okay, maybe there is more to this. It's not just about the technique. It says that it depends. You have to use cycles, which means I'm using Eevee right now, which is much faster. If I use cycles, this might actually go much slower now. I'll use GPU. Try. So render it. But for now, I don't want to play too much with this. I like this pink, so I'm going to make this I'm going to copy this value. I copy these colors without 0879. So 0879. Rendering. So 0879, 0893, and 0800. 0893 and 0800. Shading. Okay, that looks okay. And then I guess I could even do an alpha less than 1, but yeah, let me try to run this again with this material. Yeah, and then I can run this. Just see how it looks like in shading. Oh, looks different. There. Oh, maybe I used the wrong. Oh, I see what happened here. I was using RGB instead of. Where can I find emission? So emission set to Oh, this is not even used. What does this mean? Oh, look. Actually, not sure if it's being used or not. Okay, I'm not really sure what I'm doing here, so I'm just going to pick any random color. I'll spend more time maybe researching about materials and see something I like actually. But for now, we can just have one material and then change it later, right, to make it better or worse. Let's copy this. So 0.047. 0.047. We have fading. Okay, 0.047 and then 0.383. So 0.383 and then 1. Rendering. Okay, it looks a bit different, but it's okay. Right, so we have something half decent. Okay, I'm going to add this as a material. Okay. So I would be able to do this. Should I add it? So I don't want to assign like create a material for each object. I want to actually create a material once and then reuse it. It's more efficient. So this is an array modifier, so it shouldn't be too much of an issue anyway. So neuron layer. So I can create a material for each neuron layer, it's no problem. So add material to neuron layer. But then I can optimize this later. So big deal. So definition, add material, and then object, doesn't matter what it is. I can add it here. So I create a material. It's just like an example of the cube. I can add where is the material? Oh, so I can do this, right? So add material, cube dot get the object. Got this. Yeah. For now, it's going to be the same for both layers. But there's no good reason to change it anyway. So, okay, I'm going to comment this out, and I'm going to put this back. So we can run this code again, maybe with less. Let's do less neurons for the to start with, so that we don't. Yeah, it's a bit easier to just debug anything. So 8, and then that one can stay. Let's make 2, 2. Okay. Let's do this now. Okay, so it did create it. So let's have a look in shading. You can see, right? The actual neurons now have like color. So we have a color. We can also do that for the connections, but I don't know what color to put there. I don't know. I'll think about it. It could be something like metallic or something. That would be cool, right? We can do metallic. Let me just make this gap a little bit smaller. So neuron layers. Okay, instead of having a gap, such a huge gap, right? Let's make the gap half as small. See if it looks any better. Shading. Okay, so you see the difference. But let's do another material, right? If I go into rend, okay. For add material, what I can do here, right? I'm just going to define to be efficient, right? We need to create the material once and then assign it to each object. For the neurons, it's not a big deal because we only have like two objects in practice, right? We have an array modifier because we're using an array modifier and we haven't subdivided the objects yet. I think at some point I will do that, but for now there's no reason for me to do it. Probably I have to do it for the animations. When I get to that point, I need to probably light each neuron one at a time. But for the connections between neurons, we already have individual connections. They are already separate objects. So I need to add to each connection a material. I could create a constant. Create. Okay, let's do add create. So add material for neurons. Yeah, this is the one. And then I can create another method, which is to add material for synapses. And for the synapses, this is the same code actually. The only difference is the color. I'll make this more efficient later. So how do I get to? I need to create some kind of global variable, right? No, create material for synapses. So I can do that, create material for synapses, and then I can also do create material for neurons. Yeah. I don't even have to specify an object because I'm not going to take an object at this point. So I'm just going to return. Sorry, 1 second. Getting late. I should finish very soon. Okay, so we have create material for synapses and create material for neurons. So here I can create a new material, and here as well, and then return it. So return mat. Yeah. So return mat as well here. So this is the same code for now. And then here I can add all the logic. It's going to be more complex than material, most likely. So, right? So I create the material. So material, I can also give different names, so it's a bit nicer. A material for synapses. Okay. Have that. So I can call this method here, right? Create material for neurons. Yeah. And then also have okay, this is for neurons, so I'm not going to. Okay, so material for neurons, and then when I create the objects, it's going to be so I'm going to copy that statement. So object, so neuron layer dot layer the materials. Or did I dot data the materials? Append. And that's it. Yeah. And then I can do the same for connect layers. Connect neurons. Connect neurons. What is it? I'm just finding connect neurons. Oh, getting lost in the code. Okay, here. So for connect neurons, material for neurons equal to. So actually what I could do, I could take this variable outside, because this is going to be called like millions of thousands of times. I don't want to create a new material each time. Or so I could do, this might be a cop out, but create neurons material. I can't remember the name, but create material for neurons. So create material for neurons. And I create it once, yeah? And then I'm going to use it as a, just make it like even a uppercase, so it makes it very clear. It's more like a constant almost. So I'm going to do now cube.data.materials.append mat neurons. Yeah, something like that, yeah. And to be consistent, to be fair, I should do the same for the other one, regardless whether it's being done. I could actually do this at the very top, yeah. As long as I define the math. I don't know if it makes a difference, but we'll see. So material of neurons and material for this one. So so which one is it? Oh, I'm actually mixing up names as well. Okay. Glad I put them together. So material for some synapses. So, okay. Then I can use that as a constant. Neurons. And then for the layers, the connections can do math synapses. Yeah, that should work. So for now they will be the same. Yeah, it's just trying to test this. So let's delete everything that's already there. Run this. Scripting. I have some errors. So I have here an error saying, yeah, because I'm using a method before defining it. So I'm going to copy and paste this to the top. Okay. Oh, I have another error. Create material for neurons is not defined. Maybe I made a mistake with the name as well. What? No. I'm going to have to organize at some point all of these methods because it's starting to become a little bit like a long script, and this is almost the time to start creating different Python files and importing things to make things tidy. Okay, so we have shading now. You can see the connections are like also blue, right? But I want to make the different color, right? Obviously. So I can just change the color to make it white or something, more white. No, it's cool, right? So for now, I'll just make a different color. It doesn't make any sense, but it will make it at least colorful. Okay. Yeah. It'll be nice for a screenshot afterwards. Right, so I will just take this note of the color 0.013. And then 1 and then 0830. 1 and 0830. Okay. Now I can actually increase my number of nodes. without an issue. I already know this works. And yeah, it's going to be a hell of a way to finish. So I had 25 by 25, right? That's huge. But, you know, so this is, we have to finish in style. So we have, okay, it's going to take a bit of time. Yes, thank you. Yeah, Mustafa, it's starting to become a bit more like Blender-like, you know. Until now, I've only been playing with the mesh without any colors or any materials, and you know that doesn't impress anyone, I guess. But once you start adding colors and materials, it becomes a lot more interesting. But then at this point, to be honest, I have to really say that this is not my expertise, right? I don't know anything about materials. I know very little. But, you know, I know enough that I can just copy and paste code. But you know what? There's a video I put in the article. I should put this article in the description, right? Not this one, but yeah, I have this article which shows. There's a video here which explains everything about materials. It's by someone called, I think, Blender Cookie or something, or CG Cookie. He's very famous in the Blender world. Yeah, he knows all about Blender and beyond. And he explains like in a lot of detail how these materials works. And the PrincipledBSDF is actually a material. It's actually a technique for materials that comes from Disney. There's a background on that. Yeah, but. Okay, cool. We have something very cool here. Yeah, I'm going to. So this is not the full neural network. I have the full neural network. Yeah, good point. Can I pin a comment like? Oh, in the description, of course. As a comment, yeah. So the full neural network, I have it in another file. I will have to add this to the full neural network. I think I already have it, right? All the layers that I needed to visualize, I've already visualized separately, not in this file. But and then of course I need to work on the animations. I think that's going to be the fun part as well, to try and make this look like a very like interactive neural network. And yeah, if you enjoyed this video, don't forget to click the like button, and I'll see you again soon. By the way, I'll put I'm going to actually do this now. So I'm going to copy and paste this code, and I'm going to put that into a GitHub gist. Yeah, you can actually see it here, so you don't even have to trust the output there, but I would have done it anyway, but I might as well do it while I'm in the stream so you know exactly where it's going. So the way I'm doing, and for each live stream, I'm creating a new Blender file. I'm just taking a copy and paste of this code, and then I'm creating a new gist. And the idea is you'll be able to go through each live stream, and if you want to see what the code that was actually produced in that live stream without seeing any like subsequent changes, you can do that. So fully connected, I want to maybe just follow the same naming convention. So fully connected neural network. I'm just going to copy and paste his name, change the date. Yeah. So today is what, the 15th or 16th already, but I'll put 15th. And then yeah, I'll do the. Thanks to Mustafa for your suggestion. I'll put some of the links that I have in the description. Sorry, in the comments as a pinned comment. Yeah, I've used it before. Yeah, so I understand it. Okay, and create secret gist. Okay, I promise I will. If you want to have it now, I can give it to you now. And then but I'll put this in the description, and also create a pinned comment, and I'll see you again soon. Happy coding!